All right. Oops. So I'll be talking about the lower food web, and this will include things that you would expect to see in a lower food web talk. Three of these things, the spring total phosphorus, the spring chlorophyll, and mysis, have been linked with being important with forage fish production. And then mysis was recently listed as a State of Great Lakes indicator as well. So jumping right into this is some nearshore data for the spring for total phosphorus. Now, nearshore data is very regional. This data is from the Muskegon to the Grand Haven area, so it includes the Grand River, which is an important source of nutrients. And you can see that in 2023 in the spring, the phosphorus relative to the last 10 years was pretty much this line is the average for that time period. And it was pretty average, and it's actually pretty stable data for the nearshore, which is pretty unusual for that spring indicator. But if we look at the seasonal pattern for the nearshore phosphorus, we can see we have 2023 here, and then just the average for the last 6 years. We had very high total phosphorus in April compared to what we would normally see, and usually phosphorus would peak in May. We also were able to sample in January, and it was still relatively high phosphorus concentrations in January as well. So an early peak to the phosphorus in the nearshore. Next, looking at that same area for the chlorophyll concentrations, we see some variations from year to year, but 2023 for the spring chlorophyll was pretty much right there on average. And then interesting, compared to the phosphorus, we see that the seasonal pattern was very consistent with what we've seen over the last 6 years. So that big pulse of phosphorus in April didn't really translate to any chlorophyll differences in 2023 in this nearshore region. Looking at the offshore total phosphorus, and you can see we have basically 2 time periods with different states of the ecosystem. Concentrating on this latter time period, you can see there's some up and down. But again, 2023 was right there on the average for what we see for spring total phosphorus in that offshore region. Looking at the spring chlorophyll and the seasonal chlorophyll, again, we see 2 different kind of ecosystem states. 2023 was maybe slightly above what we've seen for the average, but not really all that remarkably different. Of course, the big difference that we see in the spring is we've lost our spring chlorophyll bloom. That usually would have occurred in May. But you can see relative to the last few years, there wasn't much seasonal variation in 2023. Now, May is our lowest chlorophyll in that surface mixed layer in the offshore. And again, in the offshore, we don't see any indications that that big pulse of April phosphorus in the nearshore made any difference in our chlorophyll or phosphorus in the offshore. Another feature of the chlorophyll in the offshore is a deep chlorophyll layer. There's a bunch of different ways to look at this. We look at the area under the curve. This feature would normally peak in June or July. In the offshore, there is a deep chlorophyll layer later in the summer, but it's somewhat inconsequential. And you can see there were big declines between the late 90s and 2007, 2011. In 2023, it seems to have bumped up a little bit, but it's still lower than what we saw in the late 90s. And you can see this from this, like a vertical slice of the water column. This blue line was the deep chlorophyll layer from 1995. And you can see last year in June, we still have a broad deep chlorophyll layer. It's just reduced in size to what we would have seen in the late 90s. The other thing to keep in mind here, this hypolimnetic chlorophyll, you can see how much reduced that is. And that's the area of the water column that's always in contact with mussel filtering. And so this is important because you have a lot less material that would be available for things like dipria or mysis feeding during the day in that hypolimnetic area. And then just to keep in mind how different the nearshore and the offshore are. The differences are this is data from the Muskegon nearshore site and the Muskegon offshore site. And you can see the differences are really accentuated in the spring, where even though these areas are maybe 8-10 miles apart, they're certainly connected, but they're functioning very, very differently. So just keep in mind these nearshore areas and offshore areas are functioning almost like different ecosystems. Usually in the summer, they kind of settle out and are very similar, but there was a lot more noise in the nearshore last year compared to what we usually see. So next, jumping into some zooplankton. This is the lake-wide summer zooplankton data from the EPA surveys. And you can see since the 2000s there's been kind of a downward trend, but with some up and downs during that time period. And you can see the data from 2023, or in the last couple years, is where what they classify as good. One thing to point out though, the Daphnia right here, that's the large cladoceran that would be in the offshore. That's relatively low numbers of Daphnia in 2023. Looking at that seasonal pattern, this is data from the Muskegon sites. Again, on the top we have 2023, and then on the bottom just the average from the previous 6 years. And it was a pretty normal cycle of zooplankton at that offshore site in 2023 relative to what we would expect. But again, here that dark blue is the Daphnia. Here in August we see relatively low Daphnia last year, and then again in October we see relatively low Daphnia. So that's consistent with that lake-wide data as well. Next, looking at the nearshore data, and this I don't even know where to start compared to what we normally would see. We see fairly high zooplankton in January, which is maybe somewhat surprising. In June, we should be seeing an increase in total zooplankton. We do, but it's largely related to super high abundance of veligers. July should be probably one of the highest abundances of zooplankton. It was the one among the lowest of all the months, and then it peaked in September, August, September, which is a little bit of a later peak. So a very unusual zooplankton phenology last year at our nearshore site. We did a little bit of extra work looking at that nearshore zooplankton data, seeing how those zooplankton groups related to each other across years and related to various environmental factors. And what we found were the copepods, both the calanoid and the main cyclopoid, they grouped together, and they grouped up with years with cooler temperatures and years with higher resources. So that would be phosphorus, chlorophyll, and the river flow. Those were associated with higher contributions of the copepods. And that's sort of surprising because we would normally suspect that our calanoid copepods, which are the main copepods, would be more associated with oligotrophic conditions. And then Bosmina, which is the main cladoceran in the nearshore, and veligers, those were associated with lower resources and warmer temperatures. But really, notice how veligers, they're just off on their own. So years associated with high contributions of veligers come at the expense of all those other zooplankton groups. We also looked how the zooplankton numbers were associated with those environmental factors, and this was kind of noisy, not a whole lot going on, but considering this is annual averages of zooplankton abundance across each of those years, here's a couple that are kind of worth thinking about. And what we found was as the river flow increased, those years were associated with higher zooplankton abundance. And then as the growing degree days through the spring, so warmer springs were actually associated with lower total zooplankton abundance for the year. Next, jumping into mysis, that was one of those important indicators. This is 2 time series, one from the NOAA and then one from the EPA for their lake-wide cruises. And you can see there's been ups and downs in this time series. We hit very low abundance in 2018, 2019. It was really concerning if we were definitely heading in the wrong direction. But you can see in both these time series, they've rebounded since then. Somewhat in the Muskegon time series and a little bit more so in that lake-wide time series from the EPA. Keep in mind that this NOAA time series goes back to the mid-90s. Even the highest abundances there are much lower than what we saw in the 1990s and late 1990s. This is some acoustics data collected by partners. I think you'll be hearing about this more in subsequent talks. So the only thing I really want to highlight is that mysis are most abundant in the deepest areas of the lake. And by that I mean over 150 meters. And they're concentrated in that deep water in the northern basin. So you think that has important implications for fish. There's certainly limited fish species or fish that are in those deepest areas in that part of the lake. Looking at dipraia, this isn't any new information from what you've probably already seen. Their decline is well documented, but I just wanted to point out that area where dipraia are hanging on is that same deep area in the northern basin where we see the highest concentrations of mysis as well. And then there are some other surveys for things like dipraia and the benthos. And I just want to point out in this more recent part of the data, there were none, this is for the southern basin, there were none collected in that survey in 2018 or 2021, but there were a few collected in 2022. So it does look like there are no dipraia in the southern basin from that lake-wide map. That's not true, but they're definitely rare and hovering right in that detectable level, whether we catch them or not in the surveys. Looking at quagga mussels, again, this isn't any new information, but I just want to remind us all that the quagga mussels, where they've stabilized at very high numbers, and even now they still seem to be increasing in some areas of the lake. One of the things that we've put a lot of effort into over the last few years, though, is getting a handle on mussel recruitment and the veliger dynamics. This is the seasonal pattern of veligers at the Muskegon sites for 3 different depths. Usually we see 2 peaks. We only saw really 1 peak this last year, but at that nearshore site, it was quite the peak, 1.2 million veligers per square meter on that date. That's in late June. They were over 90% of the zooplankton at that site. And so if you think about late June, that's an important time for larval fish and for also things like yearling fish that are coming out of winter needing to replenish their energy. Veligers probably aren't the best food source for that. And if they're 90% of the food out there, that's probably not great. And so we've been looking at the time series for veligers, like several of the things we looked at today. We've seen ups and downs. We can see that at our 2 deeper sites, the annual average remains in that low area. But in that nearshore site, we start to see, because of those big pulls, higher abundance. So I'm not sure if this is the anomaly or if we're going to start to be on an upcycle again, and if we're going to start to see increases in the other deeper sites as well. And then just to keep in mind, temperature controls so many of the things that we have in the lower food web. Obviously, we just experienced a very mild winter. The previous winter was mild as well. This is some thermistor data from the offshore site at Muskegon. So it's the surface water temperature and the near bottom water temperature. So you have the stratified period mixed around Christmas in that year. And then our temperature all winter during 22 to 23 was around 3.5. So usually you would be dipping down around 1 degree during that mixed period. So that was a very warm winter. Obviously this was a very warm winter, and I think we probably have some pretty good data that we'll be able to look at before what does that really mean for the whole food web coming up here. So the food web, obviously a lot of changes happened in the early 2000s. Those seem to have stabilized, but we still have year-to-year fluctuations that have important implications for fish. One of the things that we saw was a real strong impulse of phosphorus in our nearshore region last year, but it occurred early. It occurred in April. Usually it would occur in May. And it didn't really seem to translate to a whole lot in terms of phytoplankton production later in the year. And so we may be seeing mismatches where our snow melt actually from those sites, it happened in January and much earlier. So if we're seeing earlier snow melt, earlier runoff, we may be having mismatches between when the nutrients are there and when we would be experiencing phytoplankton production. Also in our near shore, we saw last year really unusual phenology in the zooplankton with that super high abundance of veligers and then very, very low summer abundance of zooplankton. And then in terms of mysis, we do seem to have recovered somewhat from those very low numbers that we saw in 2018, 2019, but keep in mind, they still remain depressed from what we would have seen in the late 90s, and they're really concentrated in a small area of the lake. And so that certainly leaves them in a vulnerable state. The dipraia and quagga mussels, the benthic surveys across the lake will be taking place in 2025. There are some more regional surveys that are taking place that we'll have data for in the interim, and they also will be keeping track of the veliger dynamics as well. And that's all I have if there's time for questions.